The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content. You can earn continuing education credits through ACI's online CEU program. Visit www.concrete.org to register. ACI conventions provide an opportunity for networking and for keeping up to date with the latest in concrete technology and practices.
Unfortunately, our final presenter, Jamie Barney of the Portland Cement Association, could not make it here. So he has asked me to try to cover his topic for you. The program is about a project that was built in New York using insulated concrete form construction. And the intent of this presentation will describe the project, talk about the energy modeling software, a comparison to actual energy data, and then conclude with some information about efforts going on at the Concrete Sustainability Hub at MIT and the outlook for green construction in the United States. The project is called the Andrew. It's in Queens, New York. It's a 50-unit multifamily residence. The developer is Bluestone Group. The energy consultant was Stephen Winter Associates. And the construction is approximately R20 insulated concrete form construction. It's about 2.5 inches of polystyrene insulation on both sides of the concrete wall. This is a picture of the Andrew residential facility and the construction. And again, you can see it's about 2.5-inch polystyrene on both sides of the 8-inch reinforced concrete wall system. The energy software that was used was TREAT, and it can be used for a variety of analyses. And it helped make a lot of the design decisions for the owner and developer of the project. TREAT software is targeted retrofit energy analysis tool. One of the reasons it was selected as the tool is it's a tool identified by the New York State Energy Research and Development Authority for use on residential and multifamily projects. It's also approved by DOE. While it is an energy analysis tool, this sort of stresses the need for why we need to do more and get more information out about thermal mass and thermal mass considerations, because this tool does not include any provisions for thermal mass. But it is widely accepted and promoted by the state of New York, and they're using it to try to demonstrate what the performance modeling is for the building types. The New York State Energy Research and Development Agency came into existence in 1975, and you heard from Steve Scalco earlier and from Jeff as well about all the things that were happening in the 70s and why there was such an emphasis on energy conservation back then. And we're seeing this greatly renewed interest as we try to pursue green and sustainable building construction and also reduce our dependency on fossil fuels. Treat is a very quick and easy model to use, which also makes it very popular. It is an attempt at predicting energy savings, and it does automatically calculate payback ratios for changes in your energy analysis design. This is the website that Treat has available, and it does allow for a wide variety of inputs. It is linked to an active screen. It allows you to modify things and build your models manually, as well as have automated inputs. And there's a library and libraries for various input screens. The Treat inputs for this particular project, the Andrew, were primarily the building overall dimensions, and it does give you the opportunity to add notes so you can keep track of changes and modifications that you're making. And while it does tell you what the heating and cooling, infiltration and ventilation loads are, it also calculates or allows you to calculate your interior, exterior, and in-unit lighting requirements and equipment loads or appliance loads, plug loads inside the building, but we're only going to focus on the top three during this presentation. It allows you to consider various fuel types, whether electricity, natural gas, or oil, and you can enter, again, it has default values that appear automatically, but you can go in and change these default values out. When they ran the calculations for the Andrew, they came up with their performance rating calculations, and they were showing savings of 48% to 65% by going with the insulated concrete form construction, that R20 solid concrete wall, versus what would have been required by the minimum energy code in the state of New York. So they got a 48% reduction in heating load, 35% in cooling, and 27% in overall performance. And most of this was not because of, again, the model doesn't reflect the thermal mass, so most of this is reflecting the tightness of the building that was achieved with the solid reinforced concrete exterior construction. But this is the comparison that was made with the R13 studs that would have been required by code versus using the ICF with an R20 construction. The annual heating and cooling load predictions for both of those systems, and when we look at the total savings between the annual load for the ICF system, which is shown here, versus the total for the steel stud system, it showed a 52% reduction. Then we got to look at the actual energy use for the building. Natural gas measured in therms and the gas charges, and there was fairly good representation, but even primarily because these are simple models, they don't get into the detail that's required. The actual performance was about 15% greater than what was modeled. So that's when that's one of the problems we face as an industry, because these simplified models do not even come close to be representative of actual building performance, especially when they're not considering the thermal mass provisions inside the buildings. But they did use it to help determine where they should put their investments as far as hard costs and paybacks, floor edge, perimeter insulation, for example, had a 185% increase in hard costs versus savings, where with the going to the ICF R20 system was about 23%. cost increase in the building. So when we're looking at realistic lifetime variations for the construction, a 60-year lifetime for the building, energy cost savings would have been about $642. The saving investment ratio would be about 2, and that's going from the R13 steel stud wall to the ICF R20 wall. And that's about this is about where we're going to see one of the better SRIs for the different things that we could do in the wall system. They did also find that if they insulated the perimeter of the floor, the edge of the floor system, to about R12, that would give them an SRI, savings to investment ratio, of about 0.55, 3.42 for adding slab-on grade insulation, a very high value. And if they looked at the 30-year life for a roof system, they could have a payback of about 1.58 by going to 4 inches of polyisocyanurate or an R21 roof system. So there is a variety of differences in performance. The steel studs has large thermal bridges that may not have been reflected in the TREAT model, as well as it did not include the effects of thermal mass. I'm told that this bit of information here is a little bit out of order because it starts looking at comparing the Andrew to similar buildings that were studied in an MIT study that only looked at Chicago and Phoenix. But the climate effects can be considerable factors in consideration as well. The Concrete Sustainability Hub is funded by the Portland Cement Association and the National Ready Mix Concrete Association. It started in 2009, and they are looking at primarily life cycle assessment modeling and life cycle assessment tools and validation of such tools for optimizing the sustainability of building projects and recognizing that energy performance is a significant portion of that load. So they are looking at single-family and multifamily residential construction as well as commercial buildings. While a little bit different than the Andrew, their model is a 4-story, 32-unit apartment building, about 33,000 square feet. The MIT used the US DOE reference model that's used for developing the ASHRAE standards and other programs. And when they look at the comparisons of the data, by changing from minimum code to these ICF wall systems, these are the total versus the ICF versus the minimum allowable wood frame construction by code shows the energy performance and cost saving reductions that you get over the buildings. So the total cost savings in CO2 equivalents, greenhouse, the MIT report is focused on the global warming potential, so they're looking at the equivalent CO2 levels for the different wall systems. And that was the initial cost. This is the life cycle cost, and there's very little difference between those different insulation strategies, whether it's the ICF or the wood construction in either Chicago or in the Phoenix markets. When we look at the energy use for the buildings in Phoenix, the energy use is less for the ICF, and again, the MIT study recognizing one of the significant benefits of ICF construction is the fact that it's much tighter construction. They looked at loose construction, which is a factor of about 0.52 versus average construction is about 0.59, and tight construction, which had a correction factor of about 1.9 or 2. So that's the differences between these constructions, is just basically changing the air changes per hour that occur within the buildings. The energy efficiency of the concrete wall systems, lower overall emissions over 60 years. They tried to demonstrate that with the TREAT model, but it was mostly looking at the tightness of the building, where the MIT models were looking more at the overall building performance in using more sophisticated models such as the DOE2 analyses. And there are opportunities to help drive a lot of these sustainability initiatives by paying better attention to the effects of thermal mass and thermal mass construction on the environment. Green is here to stay, or at least that's what is being predicted by McGraw-Hill and the PCA Economics Department. But this gives you an idea of the growth of green construction in the United States, even during this economic downturn. Of the construction that's out there, the majority of the construction is green, and it's growing about it has grown about 5 times from 2005 to 2010. So this is something that we're going to continue to have to contend with. We do need to do more things to build more sustainable and energy efficient buildings. So we're continuing to see the growth in green construction. There are some real-world case studies out there, such as the Andrew, that can demonstrate the benefits of increasing the energy performance of buildings. There's energy modeling software that's out there that needs to be tied better to real-world comparisons so that we can start using more sophisticated models. The general benefits of energy modeling are clearly being demonstrated. We cannot continue to predict or do our evaluations by using these simplistic prescriptive criteria of the codes. That modeling needs to enter the picture, and we saw a lot of that throughout the sessions today. And MIT is going to continue to do these studies for multifamily to come up with better predictions and implications, as well as working to come up with a life cycle assessment tool that looks at multiple attributes of sustainability. So I probably really butchered Jamie's presentation, but I tried to do my best to get the information to you, and I'm sure if you would like some more information or follow-up information from Jamie, you can contact him at PCA. Yes, sir.
Do you know if the interior walls were ICF also, or were they some other construction?
Interior walls were some other construction. It was the only exterior walls that were ICF.
Were they masonry, do you know? Or?
I think they were light gauge framing.
Okay. So
Like I say, and the model didn't even consider thermal mass, so.
the floors were not concrete, were they?
No, I do not believe the floors were concrete. Well, thank you all. Unless there's additional questions, some of the speakers from the whole day were here if anybody has any other questions. Well, thank you for your attendance.